Today we are going to discuss Armstrong number. Armstrong number is how do we write a program to check whether a given number is an Armstrong number or not. So what is an Armstrong number? A positive integer is called an Armstrong number of order n if A, B, C, D, and so on. Digit mayam number is data. Positive number has this many digits. Suppose this positive number has n number of digits. N number of digits then you take each of the digits. Digits most significant digit to the power n a to the power n, b to the power n, c to the power n, next d to the power n, and so on, and you take their sum. Tariba answer duga when my am tijanabagi pangiba answer duga number masama kamanagadabane. This number is exactly equal to the sum of each digit to the power n, where n is the number of digits. So for example, let us discuss an Armstrong number of 3 digits. Armstrong number of 3 digits. An Armstrong number of 3 digits is an integer such that the sum of the cubes, 3 number of digits 3 cubes. Power is cube name. An Armstrong number of 3 digits is an integer such that the sum of the cubes of its digits is equal to the number itself. For example, 371 is an Armstrong number because 371 the digit 3 and 7 and 1. So 3 to the power 3 and 3 cube plus 7 cube plus 1 cube is equal to 371. Digit number of digits to the power karaga number that number is called an Armstrong number. So this is what we mean by an Armstrong number. Now we have to write a program. We have to write a program to check whether a given number is an Armstrong number or not. So to write a program to check whether a given number is an Armstrong number or not. So first line, the first line, we're taking an input from the user. Input entered a number to be checked. Input command mana enter to number to mana string when pigani go and integer command integer function key string do integer so this is later annotated. So this integer user input to string integer okay. So this first line, it takes the input from the user and stores the number as an integer in the variable called num. Then in the next line, we check the number of digits in this number. How do we check the number of digits? First, we convert the number to a string number convert to a, then we find the length of the string. Now how many characters are there in the string? The length of the string. So we count the number of digits in this line. Next again, sum. Sum variable defined. This sum is initialized to 0. Sum 0 initialized. Okay. Next now we are going to find the sum of the digits, digits to the power n. So first, number z, user even number do. This number is assigned to another variable which is called temporary variable. The number is assigned to a temporary variable. Temporary variables. While loop while loop execute temp ki value change whenever. Temp the hapta bida namju in a direction the num give value change while loops. Last namziga samziga manabra and check the wudu yaro namji while loops change the namji change the Tamnabagi Namakta we want to keep the number as it is unchanged. So what do? We assign the number to a new variable temp. Temporary variable ni mari temporary ni aduna mari change tawjarasu kaide aduna namdasu dum yawjalerani same number do temp dasu yawlerani temp che dum change yani ko manung sa kasu kaide. So while loop sigi statement ahum jina kari hai no while temp is greater than 0, while the number is greater than 0, digit equal to temp percentage 10. So the kind of modulo division by 10. Last time we discussed a similar example. Digit equal to temp percentage 10. This means you divide the temporary number by 10 and you take the remainder. Number to 10 divide the remainder low have number to least significant digit to low have least significant digit. So for example, if I take the number as 371, number to 371 when I divide 371 by 10, I'll get 37 as the quotient and 1 as the remainder. So this remainder 1 is stored in the digit. Aduna 10 divide 10 percentage 10. Sigi meaning the 10 divide the remainder to low row. Meaning the kind of extreme right to labor least significant digit to low for having got least significant digit to low for the digit variable is stored to row. So this first line, what does it do? It identifies the least significant digit. There is a digit on the extreme right and stores that digit in the variable which is called digit. Next, I say 1G, 1G cube, so in the next step, what do we do? And least significant digit to look for do, see digit to the power n kare. N example is 3 kare. Digit to the power 3, digit cube tore, sum tinjale. And 0 1 to the power n, 1 to the power cube. Next step to temp integer division by 10. Temp have the integer division by 10 aduga store the number in temp. Sigi samini ko sigi kari hai no temp equal to temp sigi se ai sangna I haragadi temp equal to temp integer division by 10 hai ni ko sigi da sigi meaning ni ko sigi da sigi meaning jimagni temp equal to temp integer division by 10. So what is the meaning? Temp haribang sagin number do 371 do 10 and divide tawro adu quotient 2 and low quotient to low habdi kaino sagi 371 10 divide tawro what will be the quotient? 37. 37 is low sigi least significant digit it thamammo hundokro habako. So you throw away the least significant digit and you take the remaining digits, which are 3 and 7. Now that 3 and 7, this number 37, you stored in the variable temp. So temp is the hapsalo. Then 371 lemadu integer division by 10 torani. Ado achina meaning the kaino by extreme right the labor digit to hudokro memory digit to the low habani, and then you see the pangi value do temp have numbers assigned to salo. Then, so what is the value of temp now? The value of temp is 37. 37. So while loop temp 37 is greater than 0, the answer is yes. So next step execute. So then next digit equal to temp percentage 10 modulo division by 10. 37 divided by 10 and take the remainder. The remainder will be 7. 7 phangani ko. So 7 to the power n karo adu sum the tinjalo. Adu say 1 cube tinjan gre the step ta 7 cube tinjale ko. Next step ta kai la 37 g divided by 10 toro aduga quotient tam lo ro habdi kai no 7 du hundo pro 3 du dang lo ho ro haba. So aduga 3 du sig 10 hari variable hapsal lo haba. Now next time lo 3 0 di chawbra chawi adu agadi you divide 3 by 10 and take the remainder. The remainder is 3. Next step 3 to the power n do tinjalo habni. So 3 to the power cube so in 3 steps 1 cube 7 cube 3 cube next time law 3 divided by 10 magi quotient kya no 0 3 divided by 10 quotient is 0 so the law so 10 is greater than 0 no adu di tadre yare ko adu while loop se loire sigi condition satisfied to drum while loop se loire mathang step ta lae and ngasai given number do hojiki sum se hum jigi tension na bujiga given number do manabra manaragadi the number is an Armstrong number else haidi kena manadragadi the number is not an Armstrong number. Okay, so let us run this. So the I number z run torozi hojiki do 371 natra 371 enter toroge ko aduga I see enter key jinamage enter 371 is an Armstrong number. Right? Sigi program je understand to record. So 371 is an Armstrong number. Let me run this program again and let us randomly check another number. So for example, another number say for example 95 has 95 digit so not 93 has 93 is Armstrong number yang si enter key press get 93 is not an Armstrong number because 9 square is 81 3 square is 9 so 81 plus 9 is 90 90 ga 93 ga di manadre ko aduna so 93 is not an Armstrong number so let us run it again and let us check whether 92 is an Armstrong number 92 is also not an Armstrong number. So this is a program to check whether a given number is an Armstrong number or not. So let me pause the recording here. So first let us consider this example. Write a Python program to evaluate this given integral by using trapezoidal rule with 10 and 20 points. 10 points ki amu follow, 20 points ki amu follow. So the given integral is e to the power minus x square and limit from 0 to 5. Okay. So integration e to the power minus x square from 0 to 5. So let us look at how we write a program for this. So trapezoidal rule, magi formula dikai now integration fx dx from x naught initial point to the final point xn is given by h by 2 h by 2 f of x naught plus 2 times f of x1 f of x2 plus f of x2 plus and so on till f of x. See n this should be n minus 1. This should be n minus 1 n 11 it should be n minus 1. Recall f of n minus 1. This should also be f of n minus 1. Recall. Aduna sigi formula is ningjangi trapezoidal rule gi. This is the formula for trapezoidal rule. ID kaino sigi interval from x naught tagina xn. X naught tagina xn high interval g. You divide this interval into a number of equal parts. The length of each part is interval is h. Recall. Aduna x naught tagina xn interval g. You divide this interval into n number of equal parts. N number of equal parts. The smaller interval among the length h neighbor. F of x0. This is the value of the function at the first point. This is at the second point, third point, and so on. This is at the last point. So this is the formula for trapezoidal rule. F of x0 ga f of xn ga moi anigi coefficient 2 yaudi ko. The remaining f of x1, f of x2, and so on till f of xn minus 1. Moi loina ma kidi coefficient 2 yawe. So h by 2 je. See 1 by 2 half say. You take this half inside the bracket. see half the bracket si manung pusaloba. Then you group f of x naught and f of xn together. No in a class to give the integration y dx and this was y0, this was y1, this was y2, this was yn minus 1, this was yn. Yn how you do in f of x I ni ko sama ni ko. So half say 1 by 2 si bracket manung pusalo f of x0 ga f of xn ga ani pusalo f of x0 plus f of xn divided by 2 plus sigi half siga sigi 2 siga kangna grani plus the remaining mayam sigi sum lo dona sigi sum jit tare ko. So when I take half inside the bracket I get this simplified form. Sigi simplified form is in ko. So how do we write a Python program to evaluate this integral? Exam da koi matam yam changna hotpadu koi hoji Python the program ama iraga. Once the program is written, the Python program can evaluate this integral within a fraction of a second. Fraction of a second, the one evaluate to error. So let us look at the program. So what is the given function? A given function, our given function is e to the power minus x square, e to the power minus x square. So it is an exponential function. Python masamak to the exponential functions is yaw Python gi maths library do, maths module, math library do, adudagi equina exponential functions import toxilane go. Aduna from the math library we import the exponential function exp. Ereko. Adedi equina lambda function ana amat tamkibudo function ji f of x sida bu yengo sida f of x e to the power minus x square ko integrand je when integrate the function e to the power minus x square ni. So first let us define the function. Lambda function ki definition is find we f equal to lambda x e to the power minus x square. So what is the meaning of this? This means that magi meaning di kaino haru. This means that our f of x is equal to exp exponent of minus x square. Sigi meaning di sini ko lambda function gi koi gi hananda gido aduna f is a function which depends upon the variable x and the expression for the function is exponent minus x square. So f of x equal to exponent minus x square. Sini ko this is how we define a lambda function. Adudagi hoji amu yengo question premise kaino agi lower limit na 0 ni upper limit na 5 ni. Lower limit is 0, upper limit is 5. So x0 is 0, x0 is 0, xn is 5. Yaraba? Adudagi amu question kari haire. Write a Python program to evaluate the integral by using trapezoidal rule with 10 points and 20 points. Masi say 10 points and 20 points having with 10 equal intervals and 20 equal intervals and 10 equal intervals we divide it into n is the number of intervals. 10 equal intervals. Aduna to 10 points we will write only 9 because x0 however x0 however x0 x1 x2 x3 x4 and so on x9 the 10 points like never. Aduna 10 points oigi haidi n equal to 9 oitaba. Adugo 10 interval oigi harigana n equal to 10 oitaba. N is the number of smaller intervals. 0 dagina 5 okay range say I 10 equal intervals together seva. Sigi question jidi khajitang modified tawni ko with 10 points habanina 10 points haramagadi ekoi n do 9 logoni ko n 9 logoni 20 points haramagana n 19 logoni. But what are we doing here? We are doing this integration for 10 equal intervals. Yare do itadi 0 dagina 5 okay range 10 equal intervals together hare aduri interval amongi length kya warni very simple xn minus x0 divided by the total number of intervals n. This will give you the length of each small interval which is h. H pirani ko. Adudagi di next step kadore Sigi sum sia han holo ani je f of x0 plus f of xn divided by 2. So hanambada sum equal to f of x0 plus f of xn divided by 2. Sigi ani je han hole. Next a for loop ama same. For loop ama same ga sigi x1 x2 x2 till xn minus 1 box hai. Ai sigi mayam ji for ko do ne ko. Yarba. So for I in range starting from 1, we take this f of x0 plus h. This is f of x0 plus h. This is f of x0 plus twice h. F of x0 plus 3h and so on till this is f of x0 plus n minus 1h. So for I in range from 1 to n, range 1 to n higher masigi range sigi output kailakani masi 1 digi rani 1 2 3 4 5 6 till n minus 1 bulakani ko. So this will go up to n minus 1. Aduna so for each value of I, so I is 1 already, we take f of x0 plus 1h, f of x0 plus h. X0 plus h di now x1. So when I is equal to 1, this is f of x0 plus h, which is x1. X1 की value do sum dam tinjalo. Sum plus equal to habdi sum equal to sum plus this habni ko. So when I equal to 1, f of x1 ji aina sum do tinjale. Next time when I equal to 2, f of x2 sum tinjale. When I equal to 3, f of x3 tinjale, and so on till I equal to n minus 1. N minus 1 the f of x n minus 1. So we have calculated all this sum inside the bracket. Bracket manung the labor sum do equal for loops and loinam calculate tore. What remains is only to multiply the sum by h. So in the next step, we write h multiplied by sum. Sum is the h multiplied. Sum multiplied by h. Sum multiplied by h. So tore value do integral haiba variables da assign tore. So final answer is phangane. So we print the answer, print integral equal to percentage f. Percentage f the answer is a floating point number. Percentage f floating point number percentage integral. So floating point number is the integral variable j. So value do so this is formatted print, formatted output. Now I talk you the. So let me run this. The value of the integral is 0.886227. So for 10 equal intervals, the value is 0.88627. For 20 equal intervals, n change around. If you want to calculate this for 20 equal intervals, n equal to 20 happening, so run torani. Integral is 0.886227. Suppose if we want up to 9 decimal place, that is 0.9 hapo. So the 0.9 hapadi a decimal place. Abo yung be ane ba 9 decimal place po yung gaya di 0.9 f hapo. Let me run it again. 8862269225. So to di dani ko 10 daw yung asi. For 10 equal intervals, I write n equal to 10, and let me run this again. 0.886226925. So this is how we calculate the integral of a given function by using trapezoidal rule. If I give you a different function, you simply need to change the definition of this function. E to the power minus x cube I should change the neighbor. So for example, if I want to calculate for e to the power minus x cube, we simply write f equal to lambda x exponent minus x cube. And then we run this, run value minus 0.892465. aduni programming gi advantage kari no haragadi ekuna khudna hotpada calculator targo hotpada matam yam changna hotpado if we write a python program and if we run it we get the answer within a fraction of a second the answer se phangeba yaraba aduni ko so programming haitaragadi matam yam kuina sangna changadaba koi gi thabak singdo matam yam tena within a fraction of a second koi loisan ba yaya ba so this is how we calculate this, the integral by using trapezoidal rule. Okay, let me stop recording here.